Welcome everyone to today's session that is titled Accelerating CAD Digital Transformation. We are doing it in the format of a panel, and I am Eduardo Lazarotto. I'm the product manager for MicroStation and our MicroStation product line, and I'm joined here today by Nanette Dorando from our Virtuosity, which is our digital sales company within Bentley. And I'm also joined by two of our very long-term users. So we have Grant Wood from Kodiak Group that will tell us a little bit more about their workflows. And we have Gord Maguire, there's the Director of Engineering Services for the City of Hamilton. So as the first step for our panel, I would like to ask both Grant and Gord to introduce themselves and tell us a little bit more about their companies and some of their projects that they have used MicroStation for. So Grant, would you like to go first?
Sure. My name is Grant Wood, and I've been working for Kodiak Group for around 20 years now. I'm getting close to that anyway. So I started at Kodiak Group as an engineer, and after a few years, there became a necessity for somebody to help out with CAD administrative work, primarily in cell development. We have a lot of cells that we use in-house, and I helped with that when I started. As things progressed and advanced, I took over more and more of a CAD admin role, especially when Connect Edition came out, and people that used to do that either retired or didn't have as much time to do it. And then just sort of how life has taken me to this point. Kodiak Group as a company is mostly mechanical engineers. We have a couple of civil engineers. We started using MicroStation in the mid to late 90s. Back then, nobody within our industry used 3D modeling. It was kind of unheard of. Everybody did everything in 2D. It was all AutoCAD. And for what we provide, it left a lot of holes. There was a lot of challenges involved, especially with visualizing access and egress and maintenance within different facilities and factories. So that provided us an easy way to help provide a better service to our customers. Nowadays, we integrate equipment, ventilation, utilities, and everything else within these facilities. This MicroStation became our primary CAD software in the early 2000s. Since then, we've added additional technologies like Faro scanning, FEA with both RAM and ANSYS, and we do some automatic detailing with Tekla. We pride ourselves in providing turnkey solutions and solving complex problems within heavy industry. Our primary customer base would be foundries, mostly iron, some aluminum. We work with a lot of companies that make wood products like OSB and particle board, a lot of aggregates, open mines, that kind of thing. And then we do a lot of other general industry work within plastics, recycling, and a whole slew of other places. We integrate a lot of other people's equipment and models. We have to integrate existing equipment in a lot of cases, and we have to work within envelopes of existing buildings that you can't just modify because you want to. And this all has to be done within fairly tight time frames. Usually shutdowns can only last a week or two in some cases, or sometimes they have to be phased in multiple steps. These facilities can't just shut down for 2 months while you do a project. You've got to get in, get your job done, and get them back up and running. The projects can be small. It could just be a single walking beam, or maybe analyzing an existing truss to see what it would take to remove a column. They can be huge. We've done multiple greenfield facilities that start out, as nothing, and we level the ground, work with lots of different contractors and suppliers. And, as a result, some of our projects can be, on the CAD side, 1 or 2 3D models, or they could be hundreds of models. Current projects are, we're pushing 1 to 2 gigs easily in total reference information. As a result, we have hundreds of customers. And within each of those customers are dozens of projects, sometimes tens of dozens. And these projects can span everything from a day to a week to a month to multiple years. It just sort of depends. And we just try to service everybody as best we can. So a typical bigger project would start out with some kind of a concept model that takes months or years to develop. You can't just kind of fall into it. And we'll do all that development, or at least quite a bit of it. We'll even lay down the basic fundamental of what the building is going to look like. Now, we don't actually provide the end building in most cases. That's usually a different firm that specializes in that kind of thing. We would primarily focus on integrating that building, making sure that everybody's equipment's going to fit within it, and then providing all the filler equipment. So other suppliers and vendors would be providing specialty equipment for, in the case of a foundry, melting and pouring, maybe some vibratory and shakeout equipment or cooling solutions. And then we come in and try to provide the additional things that are missing. We try to integrate that equipment and then fill the gaps. So we'll provide conveyors, bucket elevators, bins, hoppers. We can provide more specialized equipment for palletizing, testing, part handling, and then even some more advanced solutions in specific cases for automatic part grinding, sawing, screening, crushing. The range doesn't really have an end. Whatever a customer needs, we try to come in there and fill the gap. Those concept models that start out pretty basic all get broken up into individual 3D models, and those models become very detailed. And we try to provide an accurate model that is an exact representation of what's going to be fabricated. This limits the amount of fit-up mistakes, it eliminates the potential problems that are going to happen, and it helps guarantee that the customer gets what they expected to get out of us, and we provided that. Connect Edition is adding new things to that. We have item type information now for purchase components, bearings, motors. All this can be added to the 3D model now, not just catalog information printed and stuck in a file someplace that has to be found later. Additionally, we're able to use some parametric cells for things like structural elements, where we've added item type information for the generally looked up and reviewed data. So this saves engineers having to go constantly reopen books and structural steel manuals to find some basic information. It's all right there in MicroStation, which can be a time saver. The new parametric tools in Connect are further helping to adapt the way that we model and making moves faster, allowing us to transition and change designs on the fly with a little bit less grunt work, you could say. Ultimately, all of our deliverables have to go to AutoCAD. That is a bit of a challenge for us. But we'll create layouts and assembly drawings. And ultimately, all of our prints work their way back to details. And we detail every bolt, every hole, everything required to put it together, and we provide whatever a shop or a customer needs to make their end product. In the long term, we aim to build and supply equipment that our customers need. We do so on time, on budget, with the quality they expect, and I think MicroStation is a big part of that for us, at least. Being able to make the exact 3D representation of what we need, but be able to do so very quickly is important. The problems that we run into so often are beyond just clash detection. Egress, maintenance access, these things are not often understood within the industry, and people ignore that if you can't get to a motor to replace it, or you can't physically walk to a location, that's a big deal. And the tools that Bentley provides make that pretty easy to do overall. And that's kind of what we do.
Great. Thank you very much, Grant. Gord, would you like to go next?
Yeah, certainly. Excellent. That was pretty fascinating. I always do wonder what's happening on the building space and the mechanical side, given that, my name is Gord McGuire. I'm the Director of Engineering Services for the City of Hamilton. We are in Ontario, Canada, kind of the west end of Lake Ontario. And we're a city of around 550,000, about 1,200 square kilometers. And the division that I operate provides civil engineering, mostly linear civil. So we do a fair amount of road, sewer, water, bridge construction on an annual basis. So we've been using the MicroStation platform now for probably over 25 years. We've moved up into the Connect Edition. Recently, we've been on ProjectWise Connect for the last couple of years. We're trying very hard to use the distributed platform to be able to deliver our programs as efficiently as we can. I think one thing that's important for people to understand is that MicroStation is really the beginning platform for everything that we do in my division, and that's for projects from a small culvert crossing to a $100 million servicing tunnel to expand development lands. It is the foundation platform that we work on, and it is from the beginning with our geomatics team all the way out to our construction group. I'm going to begin to share some screens here and maybe walk through some of our sort of standard deliverables, and then maybe a little bit of a look at some of the stuff we've been doing with MicroStation and some of the extended platforms on some other projects. So I'm going to start with what I'll call not a basic project, but a larger project for us. This is about a 1,500 meter plus about 300 or 400 meters of urbanization. So it's a large rural road that we're now converting. What we've done is we use MicroStation to model out what the new intersections are going to look like, and we use these tools in particular to promote what the project's going to look like to the public and to the affected businesses and councillors. So as we model out, we use 3D modeling, and we clamp the proposals to, or the proposed designs to our elevation models. We propose and publish these up to these websites. Gives you an indication of what the intersections, what the civil designs are going to look like as we move through these. So traditionally what we do is use the MicroStation tools and provide a link for what would be our sort of classic conventional civil drawings. And in this, here's a fairly standard civil plan over profile. We use the MicroStation tools exclusively to do these designs. We get input from storm models, we get input from transportation models, and we move through these on a project-by-project basis. And this particular project has about 12 sheets, but that's just one set. So that's probably what we would consider to be not a standard project, but one that's it's a large development-related project. I'll move on to another project. This one is in a more urbanized area. It's in what we call a business improvement district. It's already a fairly vibrant and fairly congested location to work. So what we have is this is a project website, gives you an indication of what it is that we're going to be doing out here. Some of the project, this project is completed, but this gives you an indication of where we are with the project, and as well as detour routes and parking and things like that. So it's a good overall information for the public and the residents. As we move through these, we start seeing some of the improvements that we're planning on delivering, as well as we also provide a link to our design drawings. I'll come back to that quickly. And in these instances here where we've got proposed changeouts at crossovers, those would have come out of MicroStation from the modeling as well. So again, we would use the MicroStation tools to provide these drawings. These ones are really sort of plan drawings, and they give you some indication of what the existing cross sections versus the proposed cross sections are going to look like, so that people understand from a multimodal perspective and a patio perspective where things are going to be as we move through different sections of these projects. And these have been very important for us to be able to portray what it is we're actually providing to the public. And really the last one I want to touch on here is we're using the MicroStation product together with a variety of other products to deliver a large broadband upgrade. And I think COVID's pointed out the need for internet and internet connectivity. This is a business decision by one of the Canadian telecommunication companies to do a fiber optic overlay on the majority of our city, the settled part of our city. So we're using a bunch of different tools here to chart and map the product or the project as it goes. We've got some online look at what it is that they're doing from a directional drilling and from a variety of other things. But really, I think the important elements that we've developed with this is an online solution. So we're using a cloud-based tool. We're also developed a specific workflow that lets us take the CAD and PDF drawings from the inputs and push them out through a process. Our tool box includes MicroStation, includes ProjectWise, includes a lot of different tools that we're mashing up to put it all together. I'm going to try and show.
Thanks for watching a brief overview of a fully digital solution for the design and construction management of the Bell Fiber to the Home project. The Bell team inputs their permit requests on a weekly basis using the city's ArcGIS online tools. The weekly submissions include a georeference of the location and several fields which feed directly into the city project team's KPIs for measuring project success. The permit list is organized on a dashboard for the city project team to review and process. Electronic permit files are uploaded by Bell to the city's share file transmission system to be processed by the city project team. Using CAD tools, design files are imported and validated to ensure proper standards and notation is used. Design submissions include infrastructure records from Spider and other sources, as well as proposed new infrastructure required for the project. Project designs are reviewed directly in CAD based on the city's right-of-way utility installation and permit guides, and comments are added directly into the CAD file. Once the design review is complete, the CAD is published to an iModel and includes all background information, proposed design, and the city's comments to an iPad. Conditional approval is provided for a permit design, and files are uploaded to the city's share system for the Bell team to record and review, including both CAD and PDF. The iModel design file and PDFs are uploaded to the iCloud for the city's project team to upload onto field iPads for in-field review and documentation during construction. Design files with comments are used directly in the field by the project team to further document in-field notes based on conditions. Using Bentley mobile application, the city project team is able to document written notes, markups, photos, and video. All notes and feedback is geospatially referenced for seamless transmission back to an office environment. Field comments are brought back into the office through the iCloud for review. Here we are able to see the background files, proposed design, office comments, construction notes, and as-built submissions all in one. Any discrepancies between records are flagged and further.
So I'll pause it there. We're just moving now into the restoration of the road cuts or whatever took place at that point. So from a municipal perspective, we're trying very hard to extend our use of the CAD tools. We're trying as much as we can to use cloud-based, as well as availing ourselves of sort of distributed design and distributed contractor models by sharing that data online. We're finding a lot of power in the iModel. We're exploring that at a kind of an earlier phase with the utility permits. I definitely see us exploring that a lot more in the near future as we try and get our contracts and our linear civil contracts out the door and get better field presence for it. So that's our use of MicroStation kind of at a high level, and hopefully that provides some insight as to what we do.
Thank you very much again, guys, for the introductions. I think both of them were extremely interesting. So now, if you don't mind, there are, of course, a lot of questions around both of your introductions. One of the first questions that I had, of course, was about your use of MicroStation in open modeling applications. I think both of you covered it very, very well. So maybe I'll move on into some specific questions for each of you. And Nanette, please join me as well in asking any questions. And then we can go in more detail if we lost any parts. So first question, Gord. Of course, City of Hamilton is working with very complex infrastructure projects, influencing and enhancing the life of a lot of people along the way. And you shared some of the projects with us today. Many of those projects, of course, you have a wide variety of stakeholders, all the way from the citizens, but also some of the construction companies in the supply chain that will support you through the delivery. So can you tell us a little bit more about your customization of MicroStation and the way you adapted the interface of the product to those different stakeholders? And how does that help you guaranteeing the delivery of consistent quality on time and on budget for each project?
That's an excellent question, and I do have something that we can show regarding our conversion to MicroStation Connect, the methods we used for it, and then some of the standards that we're using in driving through the what we're going to call configuration. We try hard not to use the word customization, which implies some back-end code that we don't want to have to support. So we're happy to see configurable tools and in particular the things coming out of the MicroStation product. So let me walk you through what we did to move from V8i to Connect. We built a project team in order to move forward. And again, I think I indicated that we've been with the MicroStation and Bentley product for probably around 25 years. So sometimes there's some legacy issues in our older systems that, when we move into a new version, really require us to review and revisit it. One of the things that we have been spending a lot of time on in our group is project management and project management framework around how to deliver projects and how to make sure that we're following them correctly. So we built a project management manual for this with a Gantt chart, et cetera. So that's obviously something that drove the project. I think it's interesting to note the users that we've got in here, which is our geomatics group, design, and our landscape architects and our parks and cemetery folks. We did the same thing with our schedule. I don't think we need to go through that. I think what's important here, and hopefully you can see this. This is one of those split screens of what our system used to look like, and in the past we had our aerial photography as a like a separate menu item you had to pull, and then our other planimetrics and some things like that. And then when we moved to Connect, we built workspaces specific for each group. So you're looking at a civil workspace here, giving you some ribbons and some commands directly associated with each element that we want to push into the designs or how we're working on it. And that's all driven through our seed files, and in particular comes right out of our ProjectWise and our ProjectWise templates. So that's been a pretty effective tool for us, a pretty effective conversion. And then really, I think the last thing that we put a lot of time and effort into was our CAD standards, and we went back through everything that we had in our system and had a very well-defined set of CAD standards in order that everybody understands what it is that we were doing and which systems we're using, everything from our workspace to the entire line style sets. So that's been a very effective process for us in order to move forward. So we put a lot of time and effort into that.
I also have a question to Grant. As Kodiak is in the forefront of digital design and delivers lots of projects beyond the infrastructure with MicroStation, can you tell us a little bit more about how you established your CAD design workflow to guarantee the deliverables as first time around, or to make sure that each deliverable is really used when it's finished, and no older ones are being promoted outside of your environment?
That's been 30 plus years in the making before MicroStation even existed. But I would say that it really started in the 90s when MicroStation was just a GA tool. We just made simple 3D shapes, but things really progressed, especially in the early 2000s when technology kind of caught up with what we wanted to do, and we were able to model with more accuracy. In the beginning, you couldn't make a huge facility with lots of holes and shapes because there was too much information. But that early 2000s especially allowed for all that extra modeling to happen. From there, when we moved into being a primarily MicroStation only, I think we still maintain 1 or 2 seats of AutoCAD, but that's just for checking drawings more than anything else, and importing stuff other people send us. Really being able to model everything the way we wanted it to, and then having tools that other people don't have. I think AccuDraw is undersold, if I'm honest. I think it's the best tool 3D modeling wise on the planet. I've used 4 or 5 different 3D modeling packages now, and they all suck without AccuDraw. I miss it every time I use one, and I'm sad. But, the advancements, especially in V8i with feature modeling and feature cells, which I don't think a lot of users really took advantage of. We did, because there was a lot of opportunity, especially with feature cells, to automate some pretty mundane design tasks and create cells that simplified what we did, that you input 2 or 3 numbers and then a result spits out and you can move forward with the design process. Now, going into Connect, feature cells are obviously kind of being phased out. We're moving into more parametric modeling, parametric cell work that is different. The parametric cells in particular, they're a whole new beast. They're different than feature cells were. There's some re-education involved. Thankfully, we've been super busy, so finding time to redevelop all those feature cells has been more difficult, but it's an ongoing process, and you just kind of have to pick away at it a little bit at a time. I would say a big part of it's been formulating, we've got 25-ish users, with a handful of support staff, but we've all kind of conformed to work the same way over the years. It's been a long road, but everybody kind of does things the same way within a general framework. We like to say it's playing inside of a sandbox. We all play inside the same sandbox. We try not to leave it and go play on the swings. It just makes things easier. Everybody can jump into anybody else's project and know what's going on. I think that's been a big part of it, and a lot of that comes down to training. On top of that, and something Gord touched on, customizing the interface. Our interface doesn't look anything at all like what Bentley provides out of the box. As an example, we have, and I added it up just because I was curious, we have over 5,000 .cel files that all have to be easily accessed at any given moment. Within each one of those files, there could be 1 or 2 actual cells, or there could be 100 cells that it could actually be pulled from. So we have one tab in our MicroStation environment for all of the 3D and 2D modeling tools. We have 3 tabs for cells. And providing users the ease by which to access all that information is really the way that you make productivity happen.
Thank you.
Okay, thank you very much, Grant. So maybe another question. Can you tell me a little bit more about your insights or your visions for the future around those digital twins, and how the deliverables that we have today, like 2D drawings and 3D models, will actually help building those digital twins? And then what are the big gains, or what are the big outputs for those ultimate users, like citizens in your case, in terms of safer, more efficient, cheaper, faster, or any other advantage of those projects? Can you tell us a little bit more about that?
Yeah, for sure. And I think it's pretty interesting listening to Grant and how his work is cell driven, and they're very specific to sites. And we're in a city, which we contain and control all of the elements within our own space. So what I find interesting is, we're able to use the citywide mapping system. So we can go out and we can map the entire city. We can get a drainage or a terrain model. We can get a forestry model. We can get all of everything that we need. And then when we do a site-specific drawing, we can pull in from those large data sets the things we need, and we can merge and join, our engineering-specific drawings right in with our overall CAD and GIS layers. So I think that's been one of probably our biggest and most powerful advantages, is using very tightly spatially geo-referenced drawings and projects on top of large corporate data sets, and then taking advantage of those. So sort of moving forward into your discussion around 3D modeling and digital twins, we're not quite there yet. We've invested in a couple of pretty good scanners, and we have been scanning underground infrastructure and manholes so that we get a really good look at what the clearances are. I think earlier on, Grant mentioned clash detection. One of our biggest issues as a large underground contractor is really sorting out what is underground. We run into a fair amount of on-site conflict and schedule and budget impacts because of that. So the more we can do up front, the better off we are in order to deliver a good product. But I see in particular the use of the 3D eye model, the use of that distributed design for us between the designer and whoever that is and wherever they are. Right now, it doesn't, with the COVID, it's really removed or reduced those geographic boundaries, and now the person in the field has control of the file and is using it and bringing back directly to the designer through an online product what's happening and what revisions are being made, sort of almost real time, near real time. That's something when I started I don't think I would have ever envisioned. So we're moving away from PDFs or kind of what I would like to call digital paper into kind of a real world digital. That's going to take a little while. I think there's still some reticence to move away from that, but as people adopt it and the tools become more effective and we're able to connect with everybody, that's where we're going to be headed. And sort of your point about that Bell project or that large fiber optics project. We're doing a project at scale. They're passing something like 50 or 60,000 homes a year. That's a scale that we had never anticipated before. And it's all due to the fact that we're able to share a digital file, and we're able to take advantage of the process that MicroStation's built. That's accelerated our permitting time by over 2/3 and it's definitely reduced construction issues. So yeah, some significant events taking place around this, and it's all based on the MicroStation platform.
Great, thank you very much, Gord. So Annette, would you like to?
Yeah, I have another question for Grant, if it's okay. Mm-hmm. Grant, your team manages complex projects involving multiple stakeholders with increasing pressure to deliver results faster without compromising on quality. How do you manage to consistently deliver top performance on your projects?
Communication.
That's it.
That's kind of like the big one. Yeah. We're especially seeing on these multi-year greenfield facilities, when you involve multiple parties, vendors, and suppliers that all have to be integrating, it really involves regular meetings with all the key parties and involved. They have to be super efficient. Navisworks, not a Bentley product, has been kind of instrumental in that. It's at least within our industry, it's widely adopted. Most people know how to use it without having to be told how to use it. So we will end up compiling and making 3D Navisworks models sometimes as often as weekly with updates to 3D models, so we can move forward. We may not have formal approval, but we can move forward with some pretty conceptual basic approval, and that really helps close the loop faster on problems and solutions. Customers can see what they're going to get and walk around it before it actually shows up on site, and then they're sad because we didn't give them what they wanted, or they misinterpreted what we wanted them. We're trying to tell them they were going to get. Beyond that, that same communication, we've been really working on building a network with suppliers and partners within what our industry is. And when you build a good network of suppliers, you have people you can trust. If I call or one of my colleagues were to call a shop and say, I need you guys to build this piece of equipment for me, if that shop is not capable of it because they don't have the space or the workload or the time, having an honest shop who doesn't just say, yeah, I can do that, and then they deliver it 2 months late because they didn't really have the time, that's important. So constant communication, and then I guess just being aware of who you're communicating with and taking really good notes. Beyond that, working outside of MicroStation with things like RAM elements, we do a lot of big towers packed with equipment. This would be different than just a generic open building. We're talking bins, conveyors, all kinds of big heavy stuff, ductwork hanging from ceilings everywhere that have to be sized to be full of sand and dust. And being able to crank out an efficient FEA result is kind of important. So we utilize RAM elements for that, and then we'll detail that with Tekla when it permits, and it's a good option for us. We also have ANSYS in-house that we use. Some projects can't be done in tools like RAM elements. We've done some pretty insane stuff, some bridge cranes that people wanted to put in buildings that wouldn't fit them. So we designed bridge cranes that were really, really, really shallow with some pretty obscure solutions like making tube sections, and all of that just helps, I guess. Faro point clouds probably are one of our biggest tools we've adopted. Bentley's ability to just take in a point cloud and use it. Connect especially works with point clouds so much better than V8i did. But being able to send somebody on site, instead of spending a week or 2 weeks measuring and modeling and measuring and modeling, they can go out for a day, maybe two, fly back the next day. They spend less time away from their family, away from, their kids, and they get to be back in the office sooner. And all of that is important. But ultimately, communication, and then part of communication still also boils down to training. We have a very large in-house repository of, I guess you could say it's like our own internal help desk. It's our own, it's a wiki, but it's information we just put up. So we'll have solutions for problems and we post them up. Everybody has access to it at any given moment in time. And then you have to train regularly. You have to not only train new hires, you have to train existing hires. The veterans, especially moving into Connect, they're settled in a way of doing things. Coming out of V8i, they like certain tools a lot, and actively teaching them how to use the new tools in Connect, and then seeking those new tools that you don't even know exist because they're in a menu you've never opened before. That's super important. You have to be very proactive in doing those things. If you just sort of send it out there, it's like feeding software to the wolves. It just gets chewed up and spit out. Nobody's happy. You've got to really proactively communicate and teach and train everybody in your team, and then communicate with everybody else on projects to make sure they move forward.
I absolutely agree. Thank you very much.
So for the last question, I would like you to give us a glimpse of the future. Can you please give some advice for all the architects, designers, and engineers that are currently studying and in the next couple of years will be entering our industry?
So do you want me to lead, Eduardo? Perfect. I've been thinking about this a little bit, and we talk a lot about the digital tools and how to be efficient and stuff. But I think my advice to someone who's young and getting into the business, or just getting into the business, would be early in your career, try and get as much field experience as you can. That just truly pays dividends, because when you're talking about, a project or something that's occurring, if you've got that on-site or in-field experience, it really does help understand the issues and the challenges that the field folks or whoever is delivering the other side of it. So that's probably the thing that I would recommend, no matter what business discipline or trade you're moving into. I think Grant noted earlier the inclusion of point clouds and scanning and your ability to vectorize and use that data is really a game changer. And I would recommend that whoever is pursuing any of those disciplines, it's probably applicable in one way, shape, or form, to take a really good look at that, because it's moving away from the conventional. I mentioned earlier about the integration with sort of larger corporate mapping systems and that, but there's a lot of feeds and services that you can use to augment your designs or your plans that are available if you're pushing hard on georeferencing. So maybe you asked to look forward into the future. Maybe if you give me a minute, I'll look back into the past. And it's been a little while. I've been in this industry. I started in Western Canada in a resource environment, working for an oil company, and it was pre-GPS, so we would do positioning through solar observation or star shots. So it's been a long haul, and I've seen a lot of progression in technology over the years to sort of real-time GPS out of your phone that's better positioning than we had back in those times. So, I recall loading the CAD tools with the floppy disks, and I won't bore you with that, but we've sort of come a long ways with the ability to push updates and keep the users connected to real-time downloads in the field, the iModels, the VPNs and the collaborations. It's been a sea change. I think if I look into the future, and back to my conversation about having more field experience, I see the lines blurring between design and construction, with a sort of an integrated model for folks working all the way through a project, rather than sort of, and I know there's still going to be gated and phased approaches to a lot of it. We're moving away from the digital paper, the PDF, and moving into some kind of contained design environment that allows you to work on your file and meaningfully inform the people who are trying to do asset management or upgrade your systems and things like that from a real-time perspective. For me, I think the concept of 4D, the scheduling across the whole spectrum, including the time, is pretty fascinating. I'm interested in those tools as they evolve and develop. I think they'll be more and more important. Maybe a little bit of advice on that side would be as well, whoever is getting into whatever discipline, to look at some project management training, some PMI, PMP, just so that you're familiar with the terminology and the phasing. It's critical when you're working with other larger global environments. Those are my thoughts. I certainly hope people embrace the technology and get as much out of it as I have over the last number of years. It's interesting to have a little perspective, be able to look back, and thank you for the opportunity to join in this.
Thank you, Gord. Grant, would you like to answer this one as well?
Yeah, I agree with everything Gord said there. Field experience is everything. I would say getting an internship and getting field experience, especially if you're still in college or university, is far more valuable than getting straight A's and having 4.0s for pretty much everybody I've talked to within my industry, at least. I think it's important for students in particular, and I've told a lot of students this actually, that engineering isn't always glamorous. It's not all bridges and space shuttles, and I think that's oversold in a lot of universities. I think they need to understand that there's a lot to be said for the reward of being able to do something and do it right within your industry. I would say a big one that I'm seeing is be willing to go out there and find your own answers. We get a lot of new hires that just want you to give them answers, and you learn better by learning yourself. There's certainly a part of training and a part of helping provide answers, but don't be afraid to go out there and do a little research, dig into it, to sink your fingers into it. The industry is moving, my industry is now finally getting to more and more 3D. We're seeing a lot, with Inventor and the SolidWorks and whatnot, but I think there is something to be said for maybe the industry taking a step back and also realizing that sometimes that super elegant, pretty solution isn't the best solution. Time is money, and at the end of our day, time is our only most valuable resource on everything. We all don't want to work 100 hours to do a 1-hour job, and on top of that, you can lose contracts to somebody if you spend more hours doing a thing and have to charge more as a result of it. Sometimes, if it's just a square plate with a hole in it, you can draw it on the back of a napkin. It doesn't have to be in a CAD file. And I guess I would just caution the industry as a whole to remember that. Remember that advice, that sometimes the solution doesn't have to be fancy. And I think it's important to keep that in the back of your mind so that we don't move forward looking at all of these potentials and forget where we came from, because where we came from wasn't all bad in all cases. That may sound a little bit Luddite, but it is what it is. Moving into the next decade for sure, and then decades beyond, I think as a whole, all of the CAD industries need to find a way to knowledge share better. And this would include, everybody from AutoCAD to Bentley products with MicroStation to SolidWorks, SpaceClaim, etc. Everybody still relies on things like step files, and they're really, really antiquated and they're old. And the industry needs to find a way to have a more robust method of sharing information where things don't get scaled wrong, they don't get located wrong. X, Y, and Z axis are actually maintained the same. You don't have models randomly flipping themselves over 90 degrees. I think that's going to be important for people like Gordon and myself to move forward efficiently, where we spend less time manipulating data and more time just working with it, getting our job done. Beyond that, we need to make sure that the providers of information are providing, the developers of the CAD software are maintaining a forefront thought of simple. My CAD users don't like to read help documentation. They don't even like to look at the little text in the bottom left corner of MicroStation that tells them what to click. So they'll get frustrated with a tool because it doesn't work. And I say, well, did you look at how the tool is supposed to work? And they don't want to. I think that's pretty easily solved. For the most part, Bentley's done a pretty good job of making sure that each tool works kind of the same way. But I think developers have to keep that as a cognizant thought. They can't just run off the rails going their own direction, or you just get a lot of frustrated users. And, keeping those tools intuitive is probably the best way to take advantage of that. Beyond that, I think this pandemic in particular, for my industry, has shown that we need better advances in technology to solve dealing with large quantities of data. When you're working over a VPN off of a central server with 2 gigs of reference information, it can feel like you're back in the late 80s and you open a file and then go get a cup of coffee and then chit-chat about what you're doing this weekend while you wait for that file to open. And that's not a good feeling for any user. Users don't want to sit and wait. We want to get on and keep moving. I think that's even more obvious today. People are used to things happening very, very fast, but I think the wants of the industry are moving faster than the technology is allowing. And we need to find a way to close that gap in the next decade or so that users aren't frustrated and we can move forward efficiently.
Great. Thank you, Grant and Gord, Eduardo, and Nanette. So we're just about over on time. But please continue to ask questions. If you have them, we'll continue to capture that Q&A. If you guys want to just quickly pop off mute and say a quick hi and a thank you, and we'll wrap this up.
Hello, everyone, and thank you for joining us for today's session.
Hello, everyone. Yeah, thanks again, and appreciate being part of this.
Yeah, absolutely. This was a good time. Thank you.
Great. Thank you so much.
Thank
Everybody
you.
have a great day.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.